Here's a more complicated example on a 3-point cross because in this case, the parents have a little bit of somewhat of a trans orientation. So we have these two parents. If I look at the first parent, because we are saying that these genes are linked, this is what this parent looks like. The other parent, the first gene is recessive, the second and third are dominant. We are saying these genes are linked. So I will have a progeny that is heterozygous with this orientation. Heterozygous F1 will have this. When I test cross this parent with completely homozygous parent, what are we getting as our base non-recombinant, most prolific? This and this numerically, which one is which? So if I take A, B, C is one case, A, B, C is the other. What does this look like? Correct, it's this one, 472. What does this look like? It's that one. My next step is to figure out which gene is in the middle. Well, I see the smallest numbers are 1 and 1. Heterozygous A and homozygous B and C. Homozygous A, heterozygous B and C. What do I see in the smallest number of progeny? I have homozygous, heterozygous, BC. That is the parity on this. C is different. These two are twins except for C. A and B are the same, C flipped. A and B are the same, C. That tells me that the middle gene is C. Since the middle gene is C, I'm going to mirror image what I already have. These are my majority cases with no crossover. This is going to be dominant. This is going to be recessive. I'm naming them after the first gene. I'm putting them up here. The 472 is where my first gene is dominant, and 480 is where my first gene is recessive. 480, 472. 472 is the first gene was dominant, and 480 is the first gene is recessive. I'm going to figure out where I had the split between A and C. So I'm looking for my first gene remaining the way it was, which is capital A, dominant A. And originally I should have recessive for C and B, but since I'm looking for the flip, now I should have completely heterozygous progeny right here. So this 10 is the case of first split between A and CB together. So this right here is what we used to have is A and then BC flipped to BC in our spreadsheet. That is the cross between the first gene and the middle gene. And then the opposite would be recessive A, and it got C and B. That would be our completely recessive, which is not the completely recessive parent anymore. That's the completely recessive recombination. So where am I going to put this? In here. Double crossovers are already here. So here's my 10, which is the first gene remained the same dominant, and then the first gene remained the same recessive, and everything else flipped. And then what is 13 and 15? These. That is when we had the recombination happen between the first two staying together. It's the recombination between C and B. So I should have hetero, homo, hetero. Hetero, homo, hetero. Remember, C should be homo, A and B, hetero. That's this. So 15 goes over here. And then 13 is when I should have homo, homo, hetero, because C will flip. And then the last one, I should have A and C remaining the way they were, so homo, hetero, and B should flip back to homo. So I should have homo A, hetero C. This should have been a lowercase. Homo, hetero, and homo for B. So that's going to be 13, the flip between the middle and the third gene. Once all of that is entered, you end up with 2 map units and 3 map units. So that's your example of something a little more complicated. Interference here is negative because the number of double crossovers is greater than what we expected because the genes are so close together. That happens.